Hello everyone, video 1 of module 5. In this series of videos we show you how to run the model, how to do the analysis, how to do troubleshooting, and how to read the results about displacement and internal forces. So this is the model we had before. As I promised, I completed loading and defining load combinations, and I added some other elements and some intentional mistakes to show you how to do troubleshooting. So let's explain about the model at first, see what we have, and then we will move on for analysis. I'm coming here showing you the load combinations are created. I completed all my load combinations for ultimate limited states, working stress, and serviceability limited states. So we have 2 load combinations for gravity, 8 load combinations for earthquake in X direction, 8 load combinations for earthquake in Y direction, 4 for wind, 2 for dead and live and wind, and 2 for just dead and wind, as I showed you last time. And I just repeated the same for working stress and for serviceability limited states, and then I created my envelope load combination. So if I come here, you can see all ultimate limited state load combinations are here with factor 1, and this is envelope. And I did the same for serviceability and working stress. For loading, I just added typical loads on floors. If I want to show you, I can come here to display and show object load assignments, and I can come, for example, in area, and then say I want to see superimposed dead load and apply. So you can see here I applied 1.5 kilonewton per square meter superimposed dead load. That is in addition to self weight of the structure in Z direction as a gravity load. And here I can move and go to other load combinations. So you can see it's changed to wall. If I move on, it's coming to soil, water, and other loads. So if you have all those, you can just click here simply and move on. If you just want to reach them easier and quicker, you can come here and select them. So the order you see here, this is the order it's following mainly here. So you can see here live load is 4 kPa for this level. If I move on to the other levels, I consider this area as a common area and some, for example, conference rooms or anything that we have more live load. Then our upper levels we have just 1.5 kPa typical live load for residential buildings. And when I'm moving on, you can see for this level, which is upper level, I put, for example, 5 kPa. Just assume, for example, it's a gym or again some area for gathering or conferences. Just some assumptions. And the same here for superimposed dead load. If I apply again, I can back here to superimposed dead load. You can see 2 kPa. For frame, I did the same. I can show you here just to make this area a bit clear. Let's set our view limit. I can come here and choose Z11. If I want to see just frames, I cannot come a little bit upper than Z11, because if I come upper than Z11, the elements are partially below Z11 wouldn't be seen. So if I come here, for example, even put 11.2 and press apply, you don't see the columns anymore. But if I put 11, then I see the lower level, which is exactly at Z11. How can I just make it clear for myself? I can come here, simply rotate it in this angle, and then I can select all elements above, and the easiest way is just assign them to a group. So I'm coming here, creating a group. I've done this, but I'm just selecting again here. I added a group name top steel frame. I'll replace it and apply. And when I back to the 3D, I can simply use my preview selection and then show selection only. Now I just can see the still frame above. So let's see what we have here. Coming again here in display, object load assignment for frame, and I applied dead and live and wind loads. So this is live load. So live load here, I assume 0.25 kPa live load because this is a non-trafficable roof. Again, this is based on Australian standard. I just put some numbers for our practice. So 0.75 and here 1.5. Just for simplicity, I assume all the spans are 6 meters. They are not exactly 6 meters, maybe 5 or 7. You guys need to calculate the tributary area of each frame separately and calculate the loads and apply the loads manually. But just for simplicity, I consider that all of them are 6 meters. That's why the loads are the same. So 1.5 kilonewton per meter for the middle frames and 0.75 kilonewton per meter for end frames. And I did the same for superimposed dead load. I considered 30 kilogram per square meter or 0.3 kPa superimposed dead load, and you can see here for 3 meters 0.9 and for 6 meters is 1.8. Then I applied wind load. Coming here, for example, wind xn, and you see wind xn means wind in the other direction. So here I can zoom. So the load here is 4.8. If I come to the other side, the load is windward, so here is 3. We have side winds outward based on the factors we have in our standard, so I put 2.4 here. So you see the corner columns are taking half of the load for each side. So this is wind xn. Now I want to see other wind loads, so I go for wind xp. I apply. You can see now this is windward and this is leeward, and again this is side. I can choose this one. Just bear in mind that this is not following exactly the same pattern and arrangement of the wind you have here. So the next one is not necessarily wind yn. If I press here, it's coming to wind xn, and when I'm going up now is wind yp. So just bear in mind when you're checking, don't think that you are exactly following this. So the wind yp, you can see here again, now this is windward, the other side is leeward, and those are side. And the same yn, and you see that I also applied the roof wind load. This is generally I consider just upward wind load, and I applied it. So if I back to X, you can see that the roof is also loaded. So those are for wind load. I also added thermal load everywhere. So if I come here again in display and come to object load assignment to frame and choose here thermal, you can see the roof elements are 20 degrees plus 20 degrees. That means they are subjected to expansion. So those are generally the loads we have, and I can show you some other assignments I had. Let's just back to undeformed shape. So let's see what we have here for end release. So for end release, I can come here again, display. I can come here to element assignment, and I can come to frame and ask what I want to see. So here I want to see releases and partial fixity. I apply, and you can see that all those green ones shows that those elements are pinned connection. So when we say pin, is not necessarily all of them. This is just a sign. You need to know what you have done. Sometimes you may just release M33. That means moment in three directions. So 3 is generally 2 is upward, 1 is along the element, and 3 is the side. So M33 generally is the major moments of the elements. So when you have it, then you can see what you actually you have applied here. But you need to right click on the element and you need to check them. All you can see here is there is a pin connection, there is a release, but what type of pin or release you have at the end, you need to check it here. So here is currently torsion moment in 2 and 3 directions in one end, and the other side is just moment 2 and 3. As I said, when you want to draw an element, you choose pin connection. SAP automatically use this arrangement. If you don't want to have torsion, then you need to assign it later on yourself. So those are for pin connections. I haven't done it for the wall posts or wind columns. So at the end, if you remember, we chose moment resisting frame. So the main frame, the columns are this column, and the end column. These columns at the middle is just helping me for gravity load, not lateral load. So for wind column here, I have two options. Either just connect it to the frame like what it is. Sometimes you have a slotted connection on top, and that wind column just taking the lateral load of the wind and is not taking the gravity load of the frame. How we can do that? We can come here in element release, assign frame release, or we can come here in this menu, assign frame, and come to release. And here what I need to do, I need to first of all ensure which one is end I, which one is end J. I believe this is end I, so let's try when we can see the sign here very quickly. I'm coming here and I said at the end axial load is released and I apply. Yes, that's correct. So that was NJ. So you can see the axial load is released. You see there's no difference between the sign of end release, but here moment and torsion is released, here is just axial load. So that's why you need to be very mindful when you are applying. Just you need to check it manually later if you want. Again, I'm doing the same here. I'm selecting those elements and then apply the same. So those are my wind columns. They just taking the wind load. They're not participating in taking the gravity load of the frame. It's up to you guys, really, back to the structural system you have, but I'm just showing you what you can do. So the other thing I would like to share is end offset of the frames. If you come here, you can clarify what's the rigid zone of the beam to column connection, because when SAP gives you the moment, SAP gives you the moment at the axis and center line of the column, and actually your design moment is at the edge of the column. So half of the height of the column can be ignored, and the moment could be a little bit less, and that would be more cost effective in your design, and this is correct. So how you can assign it? You can assign the beams, and then you can come here, assign frame end length offset, or you can come again to assign and coming to assign frame, and in frame you can come to end length offset. What you need to do here, you can assign yourself if you know exactly the size of columns, but sometimes you have variety of sizes. It's very hard to assign manually. Better to leave it to software and mention automatically from connectivity, and here you need to mention what's the rigid zone. So those are auto. If you put for user define, you need to define them manually. For example, for this frame, those sections are 310 universal beam, so the height of the beam is about 310 millimeter for both columns and beams. So if I want to choose any rigid zone here, that would be half of the height, is roughly 0.155. So 0.155, and I can choose 50%, and then I apply. So how we can see that, just for clarity, I changed the color of these elements. So I'm coming here, 310 UV. I just changed it to a lighter color to be able to see the rigid zone. So I redraw here. Okay. So this is end offset. So if I come closer, you see a small sign here that shows the end offset. This is what I define. If I go for automatic and 50% and then select these two and apply, you see here is 0. So if I right click here, the default coming as 0. It back to the software to see what is right. So if, because the this element is very long, that's why it doesn't show anything. If I come here for automatic, I can see these numbers for end I and end J. If I back to my user define and again apply here and right click, you can see here the numbers with 50% of rigidity. So it's up to you guys how you want to apply. You can simply come to the whole model and then select them all and come to assign and frame and end offset and set automatic with 50% and apply, and then leave it to the software to choose which one needs end rigid zone, which one doesn't. So you can see here the end rigid zones. So whenever you have the connection and the length is reasonably low, you have rigid zone. Rigid zone is not necessarily for moment resisting frames. Even the frames with end release, they may have rigid zone, but it doesn't change anything for them because rigid zone mainly help you to reduce the moment. Otherwise axial load would be the same. Okay, so this is for defining some other boundaries and some other conditions for elements before we running our analysis.